L13.4, Part C. Now how do we come up with two triangles? Well, with the length of 10 for side A, it's long enough to reach the third side, but short enough so that if you swung it to the other side of that right triangle side, it would still create another angle. But this one over here would be obtuse, whereas this one would be acute. So how do we find them? Well, we start out with the same idea. Law of sines. So sine of 39, which is angle A over its opposite side, 10, equals, negative 14, so we are looking for angle B. Cross multiply that, and we get sine of B equal to 0.881. If you sine inverse of that, angle B will be 62 degrees. Now at this point, I want to also mention how we get another degree besides 62. And that is, we've just got done with our unit circles. If you remember, sine is the y-coordinate. So we have cosine, sine. And on the unit circle, sine is positive in the first and second quadrants. So if I had 62 degrees, then I would have a sine of 0.881. If you remember, the unit circle is symmetrical. So if I went this way, the sine of that point would also be 0.881. Even though the x value would be negative. But the y value, the sine value, is still positive. So what is that measurement then? Well, we're looking for this measurement. And that is 180 minus 62, which is 118. So B is equal to 62 degrees, that's one triangle, and 118. And that is where our second triangle comes from. So we're going to finish with 62 first. Alright, so if angle B is 62 degrees, then angle C must be 79 degrees, because if you add 39, or take 180 minus 39 minus 62, you get 79 degrees. Then we will find last side C. So let's go sine 39 again over 10 equals, now we're looking for side C, so let's go sine of 79. If we cross multiply there, side C, it gives approximately 15.598. And that is solving one of the two triangles right there. Now let's do the other scenario. What if angle B is equal to 118? And that would make angle C then 180 minus 39 minus 118 will give us angle C of 23 degrees instead. So we go back and we would say sine 39 over 10. Use our newfound knowledge of 23 to find side C now. We cross product that, side C in this triangle would be approximately 6.209. It's because of this that you could have two possible triangles. But again, it only worked because we had 14 for side B, which was greater than side A, but that was greater than 8.81, which was B sine of A. So every time we do this, we're going to have to look at what that value is to decide if there's going to be no triangles possible, one triangle, or two triangles. Again, the key here is to know when there's two triangles possible, because if you don't acknowledge that fact, then you would stop after this triangle thinking you were done. But when indeed you had one more triangle that was possible. Here ends Lesson 13.4, Part C.